Hello. Okay, so we are moving on to section 7.4, where we are establishing identities. So what that means is you're either trying to get, like you'll see in the first example 1A, oh, that was my phone. That was really loud. That was my mom. Okay, you're either trying to get some sort of sum or difference or ratio into one trig function, or you're trying to make one side look like the other. Okay, so we have all of our different identities at the top of our notes, and then guidelines for establishing identities. First, it's almost always preferable to start with a side containing more complicated expression. I cannot express this enough. You want to work with more, because if you're trying to go from simple to complicated, it gets way more complicated than going from complicated to simple. Okay. Rewrite sums or differences of quotients as a single quotient. So that means get common denominators and then combine them. That is an excellent tactic for trying to establish or simplify. Number 3, sometimes rewriting one side in terms of sine and cosine functions only will help, so keep that in mind. And then number 4, always keep your goal in mind. This is so huge. Know where you're going. Where am I trying to get to? So as you manipulate one side, you must keep in mind the form of the expression on the other. I don't want to try to combine two trig functions if I'm trying to make it look like two trig functions being added. That's silly. But I don't want to keep two trig functions separate if I'm trying to get to one. Okay, so really always keep in mind your goal. Where am I going? What am I trying to get it to look like? And for those of you that always like one way to do something, well, this is not your game. There are definitely preferred methods, and the more you do, the more you'll see, oh, it's this setup. I like to solve it this way. So maybe it's I like to multiply by the conjugate or whatever. There isn't just one way to do these. And I know that first time, like it seems to be in my experience, half of that, my students hate that. But you just have to practice. The more you practice, the easier it's going to get. Okay, so I'm going to show you, what do I have? A, B, C, D. I'm going to show you 4 different possibilities, okay, 4 different options. So if you look at A, tangent of theta over secant of theta. Well, we can start by rewriting this in terms of sine and cosine. Okay, so that means that I'm going to say that the tangent of theta is being divided by the secant of theta. Okay, ratios are just division. And then I'm going to change this to be, well, sine of theta over cosine theta for tangent being divided by, not that, 1 over the cosine of theta, because that's secant. Secant needs to be the reciprocal, yeah? So then for fractions, we keep the first fraction the same, change division to multiplication, and then it becomes cosine of theta over 1, and those reduce, and this simplifies to sine of theta, and we can't go any further. So one possible option when establishing or simplifying is to pull it apart. Okay, it's a ratio. Let's pull it out into division, see what we can change from there. B, show that one side equals the other. Okay, huge. Please write this down. You cannot manipulate both sides at the same time. Okay, in other words, you have to work with one side only at the same time. If I were you, I would write work with one side only. Okay, so when you're asked to make one side look like the other and you work with both sides, immediately it's off the table. You have to just manipulate one side to show that it can be the other. It's not trying to make them both look like each other. Okay, so we're going to multiply the numerator and the denominator by the conjugate. Conjugate is the same binomial, but the opposite operation. So what we're going to do is we're going to multiply 1 minus cosine of theta to the numerator, and then 1 minus cosine of theta to the denominator. In doing so, on the left-hand side, we get sine theta times 1 minus cosine theta all over. When we multiply these two together, we get 1 minus cosine squared theta. And I'm not going to distribute in the numerator because I'm trying to get one side to look like the other. I don't really know where I'm going. The more simplified it is, the more I can manipulate, unless I see something that forces me to multiply through. And right now I'm not there. Okay, I see the denominator and I see that it's one of our Pythagorean theorems. So I can change that to be sine squared theta. I'm not going to write the right-hand side because it's not the one I'm working with. It doesn't matter at this point. I can reduce 1, so then I get 1 minus, hey, where am I? I'm exactly where I need to be. Okay, when you're at your final step, that's when you write the full sentence and you're done. Okay, so don't write the full sentence until you're finally done. Here we're asked to simplify over a common denominator. Okay, well, they're entirely different. So I'm going to multiply the left by 1 plus sine of u over 1 plus sine of u. Okay, if you do it by the same in the top and the bottom, that means that you're really multiplying by 1. So it doesn't necessarily matter what you multiply by as long as it's the same on the top and the bottom. And the right will do by 1 minus sine of u over 1 minus sine of u. So we get 1 plus sine u over 1 minus sine squared of u. And then plus 1 minus sine u all over 1 minus sine squared of u. Real quick, conjugates. If I were, let's go over here to the thought bubble. If I have, let's say, 1 minus x times 1 plus x, and you were to multiply them together, you get this. What happens to the middles? They cancel out. So you get the first, oh, hello, multiplied, oh, golly, by the last. Okay, that is the conjugate. So that's why I'm not going through the whole first outside, inside, last, is because I don't need to. They're conjugates. All right, so then up top, we get 1 and 1, so that is 2. These cancel. So 2 over 1 minus sine squared u. Well, it doesn't matter x, u, theta. What matters is that it is our input, right? So this becomes 2 over cosine squared of u, which is 2 times 1 over cosine squared u. Why would I do this? Because I know that it's a reciprocal, and I know that up here, it's the reciprocal identity. If you can simplify the identity, you must. Do not leave the reciprocals. So this becomes 2 secant squared of u. Excellent. All right, the last one that you might see is if we were to factor. Okay, so right off the bat, the numerator can become sine squared of v. And in the denominator, I see that they have sine v in common. So I factor that out. Okay, well, you can reduce the numerator and the denominator. So you have sine of v all over 1 plus cosine of v. And then you want to try to break it down as much as possible. So, gosh, looking at this, I would leave it, to be honest. Okay, so I would leave that as is. Now, some of you might see the numerator as being able to factor 1 plus cosine of v times 1 minus cosine of v, and you're not wrong. Okay, there are different options here. And that causes us to cancel out one of the factors, and we're left with 1 minus cosine of v all over sine of v. Either one I would have accepted. Please know you have those options, okay? All right, so let's do it. I've got 1, 2, 3, 4, 6. Yeah, buddy. All right, now there's no easy way of learning this, you guys. I said that at the beginning. It's trial and error. Sorry, I was thirsty. If my throat was dry. If you start on one side and you're stuck, you need to stop. You need to go back, okay? Do not work from both sides at the same time. I cannot stress that enough. Your textbook will show you one way. It's not the only way, okay? Play and play and play around with it. You'll eventually figure out what works best for you, okay? I'm going to do these in my viewpoint. If you see a different way, rad. Try it out, okay? All right, so this has an equal sign, which means I'm trying to make one side look like the other. Right away, the left is more complicated. So I have a sine of theta on the outside. I'm going to try to write cosine, cotangent and tangent in terms of sine and cosine. Why? Because I have a sine on the outside, and I'm thinking that it might help me. Okay, so then I'm going to distribute the sine inside, and that leaves me with cosine of theta plus sine squared theta over cosine theta. Okay, I'm going to get common denominators, so I get cosine squared theta over cosine theta plus sine squared theta over cosine theta. Combining them in the numerator, I get cosine squared theta plus sine squared theta all over cosine theta. Sine squared plus cosine squared, or cosine squared plus sine squared, is 1. So you get 1 over cosine of theta, which is secant of theta, which is what we were trying to do. Nice. Okay, this one is different. You can approach it with the left or the right. I personally am going to approach it with the right-hand side because I know that I can multiply by the conjugate and get something fancy in the denominator. Okay, so in the numerator, I'm not going to distribute. Remember, if you don't distribute, you can see maybe where it's going to lead. You got to give it a minute. Okay, so in the denominator, we get 1 minus cosine squared theta, which we know to be, ooh, I forgot my theta, sorry, which we know to be sine squared theta, Pythagorean identity. One of the signs cancel out. So we get 1 minus cosine theta over sine theta. Okay, here's where we have to stop and really think about where we're going. I'm trying to get two terms being subtracted. So let's do that. 1 minus sine theta, or 1 over sine theta, sorry, minus cosine theta over sine theta. 1 over sine theta is cosecant theta, there it is, minus cotangent of theta. Always think about where you're going. Okay, we might have gotten stuck here, but remember, I need two terms that are being subtracted. So let's do that. Okay, take a look at C. My squeaky chair. I don't know if you guys can hear that. Whoo, the left side is definitely the more complicated. Well, we know that there's a subtraction being divided by subtraction. So I'm going to split this out to be sine squared theta minus sine theta over cosine theta, because that's what tangent of theta is. And I'm going to divide that by the denominator, which is cosine squared theta minus cosine of theta over sine theta. Okay, well, I can't keep change flip because I don't have just two ratios, and that's only applying to fractions. So I'm going to get common denominators, and I'm going to say that sine squared theta cosine theta minus sine theta all over cosine theta. I did definitely skip a step, sorry. And then divided by cosine squared theta. I'm getting common denominators here. That might help. Sine theta minus cosine theta all over sine theta. Now I have one fraction being divided by another fraction, so I can keep that. So I can say that sine squared theta cosine theta minus sine theta all over cosine theta is being multiplied by sine theta all over cosine squared theta sine theta minus cosine theta. Okay, this is a big mess, right? It's ugly. What in the world? We're trying to get to tangent squared theta. Don't quit. Keep going and see what happens. In the numerator on the first fraction, I can factor out a sine theta. And that's going to leave me with sine theta cosine theta minus 1 all over cosine theta. Still don't know what's happening, but stick with me. In the denominator of the second fraction, you can factor out a cosine theta. And that leaves you with cosine theta sine theta minus 1. Oh, yep, those can cancel because they're exactly the same. So you're left with sine squared theta over cosine squared theta, which is tangent squared of theta. Don't give up. That's the moral of this story. They're going to get wacky. They're going to get weird. They're going to get ugly. Just keep playing with it and see where it leads you. Okay, so left versus the right. We need to make one side look like the other. Let's go ahead and work with the right. I'm going to multiply by the conjugate. Why? Because I can. Because I know that in multiplying by the conjugate, the numerator will work out to be something beautiful. So we get 1 minus sine squared theta over cosine theta times 1 minus sine theta. I know that my numerator is a Pythagorean theorem. So what Pythagorean identity? So that 1 minus sine squared theta can become cosine squared theta all over cosine theta times 1 minus sine theta. One of them can reduce. Oh, hey now. So we get cosine of theta over 1 minus sine theta, which is exactly what we were hoping for. So that one was nice and easy. Okay, take a look at E. What shall we do with E? Again, multiple different options. The left-hand side is way easier, or simpler, I shouldn't say easier, than the right because it's just one trig function. Let's deal with the right. We know that this is cosecant theta minus sine theta divided by sine theta. Okay, so that leaves us with cosecant is the reciprocal of 1 over sine theta minus sine theta times 1 over sine theta. I was able to flip the right hand side because that is just one term. Okay, normally you couldn't. Let's go ahead and get common denominators. So we get 1 over sine theta minus sine squared theta over sine theta, still times 1 over sine theta. Okay, so this leads us to combining 1 minus sine squared theta over sine theta times 1 over sine theta. Okay, I'm going to do two different things. Oh, just kidding, I won't. Okay, so in the numerator, when we multiply, we get 1 minus sine squared theta over sine squared theta. 1 minus sine squared theta is cosine squared theta. We should know that by now. It's our Pythagorean identity. So we get cosine squared theta over sine squared theta, which is dun, dun, cotangent squared theta. Awesome. It's so nice when they're easy, clean, and beautiful like that. I think for sure the weirdest one that you guys have seen was this guy, because it's like, where do I go? There's so many. It was easy. You just pull it apart, get common denominators, and go from there. All right, last but not least, ladies and gents, F. I say start with the left. Come on, we can do it. Okay, so we have 1 minus cosecant is 1 over sine theta times sine cubed theta. Well, these two are getting multiplied together. So you get 1 minus sine squared theta. Looked crazy, right? This is the Pythagorean identity. So you get cosine squared theta is equal to cosine squared theta. I promise you, they are not scary. They're not, well, maybe they're a little scary at first, but if you guys have your identities right next to you, remember the even odds, reciprocals, all those good ones. Pythagoreans are by far the ones that are used the most. And remember your guidelines. What can I do? What can I not do? You'll be just fine. And there's 2 homework assignments that are attached with this. Don't do them both at the same time, please. Do one, let it marinate a little bit. Think about it. Think about what you did, what you should have done, what you did right, and then attempt the second one. Awesome. Thanks. Good luck.